Let's talk about gravity. As many of you know, gravity is the force that pulls things from above the Earth down to the ground. This is a very specific form of what gravity does. And to talk about the more general form, we're going to have to take a look at this equation right here. From this equation, we can see that the force of gravity is equal to the gravitational constant g, big G, which is important, and then it is multiplied by m1 and m2 divided by the radius squared. This radius is the distance between the center of the two masses. And notice that the two masses are multiplied together, meaning that if you have two very large masses, you'll have a very large gravitational force. But if they're very, very far away from each other, you'll see that the r squared also becomes very large and thus decreasing the gravitational force. The r squared on the bottom means that the gravitational force drops off very quickly with distance. On the surface of the Earth, however, the distance between any object that we have and the center of the Earth is pretty much constant, which means that we can assume that the distance between the mass 1 and mass 2 is the same for any fall of basically any height, because the Earth is very big. This allows us to do some multiplication, and then we get the very common constant small g, which is 9.8 meters per second squared, that many of you will know from your physics classes. Since that r is basically constant, and g is a constant, and the mass 2, which I will call mass 2 the mass of the Earth, since all of those are constant, we just group them all into a little g, and then multiply that by m, and then that's how we get our gravitational constant anywhere on the surface of the Earth.